Thanks for joining us with the fundamentals of Passive House here today. Here with Bronwyn Barry, and we're going to cover just a few things today. We're going to talk a bit about who Passive House California is, and our mission, membership, and then and what we have upcoming events. Bronwyn's going to take us through some kind of technical details, what Passive House Fundamentals looks like, and we'll get a bit more detail about what kind of upcoming events and training we have, and we'll have 20 minutes for discussion. So our mission statement as Passive House California focuses on education and for the Passive House community. And Passive House, really, we look at trying to design not just its energy efficient, but healthy, comfortable, durable, and resource efficient buildings. So our members are very active, and this is the kind of thing we try to promote. We try to promote more buildings and development in California. And become a member to support your local Passive House community. And one of the major benefits of becoming a Passive House member is the discounts to our events, plus our NFPHN events, which we're affiliated with. You get to vote on policy changes and your board of directors, which get elected every year. And you get listed on a website as a member, and you get to upload your projects to our website for more publicity. You also get, as a professional member, you get more access to IFA with access to the International Passive House Database and Passipedia, as well as discounts to the International Passive House Conference. We have a lot of upcoming events this year. We have coming up very soon in April, we have the Passive House Consultant and Designer Training led by PHA. And then in May, we have 2 technical software trainings by Andrew Peel. We have the PHPP software training, which is a 3-day class, and then the Design PH training, also by Andrew Peel. And we'll get a bit more into detail of what you can expect from those later on. Also in May, just following that, we have an open house tour with details to be discussed, disclosed later. And then very soon after that, we have 2 events. We're hosting the same event twice, one during the daytime in San Francisco, one on the weekend in Palo Alto. So hopefully everyone can make that. Later on in the year, we have a homeowner panel and more training. And then we have our major event for the year later on in November, which will be a materials showcase and a repeat of the Pedal House tour that we did last year that was very successful. And then in December, we'll have our holiday party and AGM. So I'm going to pass it over to Bronwyn, who will lead you through a discussion about some fundamentals on Passive House.
Thank you, Lizzie. So I'm just going to share my screen here and get it all back up in the present mode. So I'm going to take it from where Lizzie left off. And what I'm going to be doing today is covering the essential fundamentals of Passive House, and then looking at a broad variety of building types that are all Passive House buildings, just to give a really good overview of how this methodology can be applied to a massive range of buildings, essentially all types of buildings, and how it has been implemented elsewhere. So most of these projects I have visited personally. These are my own pictures, and then there's a few other pictures in here that Andrew Mitchler has kindly shared with us. So essentially, Passive House is an approach to building that is based on this radical idea of building for optimum human comfort, which I personally found quite refreshing, that it's not just about getting to great energy targets. It's really about building for really wonderfully comfortable living and working spaces. It as a sort of side benefit, it happens to deliver incredible quality and resilience, which includes good durability, and has some great health and indoor air quality benefits. And what we found over the years is really Passive House actually requires integrated project delivery. It's a team sport that really has to be played in the most well-coordinated way in order to be successful. We've also seen how Passive House does focus both on this comfort and energy, but can very well and easily be integrated with other standards. So it plays well with others, like LEED and Living Building Challenge. So there's usually not much conflict in terms of having it be part of those other systems as well. So the strategy implemented by Passive House is essentially based on really good building science and the physics of heat flow. The envelope, which is your walls, your floors, your roof, and your windows, is typically really characterized by a great insulation layer. So it's sort of super insulated, but what super insulated in California is different to what super insulated in Minnesota means. And so the insulation levels really are adjusted to your local climate conditions. And most people have heard about the air tightness requirement for Passive House. And it's interestingly, usually the thing that people are the most scared of on their first project. And that fades away and becomes less and less critical once people have experienced and are experienced in how to get their details to make their building really easily airtight and well sealed. The other myth for Passive House is you can't open your windows. This is absolutely not true. Certified projects actually all require an operable window in each habitable room. And you can leave your doors and windows open all throughout the year if you so choose. Obviously in winter and some of the storms and hottest parts of the year, most people close their windows and doors anyway. The other item is thermal bridge free construction. This is something that our building community is still really getting their heads around. And what it becomes quite clear in Passive House is how important those details actually are. So a thermal bridge is essentially a junction or a connection of materials that creates a heat or cooling superhighway, which if you're going to the trouble of making a nice super insulated building envelope, you obviously don't want to negate all the benefit of that by then creating these thermal bridges in your building that essentially become the heat and cooling leaks. So your details have to be very carefully considered. There is a methodology for calculating your thermal bridges because there are occasions when it's really just impossible to avoid them, particularly in retrofits. But you can mitigate their influence and their negative impact on your building to a large degree. But when you can't, you can also calculate them and include that in your design calculus for the energy in the Passive House planning package. And we'll get to the Passive House planning package in a little bit further along here. So the concept, I'm looking at the third item here, is really heating and cooling load reduction. So the whole point of the air tightness and the insulation is to really minimize the rate of heat loss or cooling loss from your building. So you essentially slow down the amount of energy that is lost from inside your building. So you can control it much easier, and you don't have to waste a lot of it. And this goes to the savings benefit, where if you have carefully controlled your heating and cooling losses by these passive measures in your building envelope, you then don't need to provide as much heating or cooling in your building. So while the equipment is not eliminated altogether, active heating and cooling is required in most passive houses. The amount that is required is drastically reduced. Then just a few of the other items that are pretty typical and very relevant for passive house. The occupant heating factor is usually calculated pretty carefully in passive house. We are all walking heaters and put off quite a bit of heat and energy, and this is calculated and included in the load calculations for passive house. Windows are a very critical component for passive house because these are essentially the weakest link in our whole building envelope. So specifying and installing really good windows is a very critical component of passive house, and one of probably the most toughest items to both specify and procure in most passive houses, particularly when it's a fairly new concept for wherever you're building. Solar heat gain is a factor that is always carefully controlled in passive house. I will caution though that for passive house, solar control is much more beneficial than actually maximizing solar heat gain, particularly in climates like ours here in California, where we actually have a lot of sun. What we're finding is keeping the heat out, but the light, allowing the light to still come in, is one of the trickiest balances that passive house designers and builders are having here, and it's one of our biggest challenges to ensure that we're not being too greedy with solar heat gain. And then, of course, the other very salient feature and very typical of all passive houses, except for a few in very benign and mild climates, is this idea of a heat recovery ventilation and a balanced ventilation system. So the diagram here to the left is showing this fresh air exchange with fresh air coming in and having the energy from the extract air transferred to the fresh air without the air sources actually mixing. And then the stale exhaust air from the interior is extracted and vented to the exterior. So this continual supply of fresh air is a really wonderful feature of passive houses, and it's also critical to passive house because when you create a very well-sealed building envelope, you are reliant on occupants without putting in ventilation and heat recovery. You are reliant on occupants for opening and closing windows, and we've seen from multiple studies by various experts around the world, occupants are not a good, reliable method for creating constant fresh air supply in buildings. And there are many buildings that, of course, you can't open the windows. So mechanically ventilating them is critical, and also is really the foundation of the good indoor air quality, and ensuring that any toxins and off-gassing that happens naturally, even from benign materials and humans, is also extracted from the building envelope. And then lastly on my list here, foundation insulation, insulating the ground from the ground floor or the foundation from the earth is very necessary, even in our own fairly mild climate. Our earth temperature here is around 56 to 63. If you think that optimum indoor temperature is about 70 to 72 degrees, that's a big temperature delta. And by insulating that, you can actually decouple the floor from your ground temperature and control your interior comfort a lot easier with a little bit of insulation. So that's the real big picture overview of the strategy used in all passive houses. And we'll go through and look at some of the details and projects that how it's been applied. But before we do that, I'll just give a brief overview of the certification metrics. And I do want to add here that there are different certifications available in North America. The certification metrics for the FIAS Plus standard are very location specific. So they vary from one town to the next and need to be looked at completely separately from these metrics. This is the Passive House International certification, and there are three hard certification requirements. The first being to do with your heating or cooling demand or load, and this is a sort of a flexible optional. You can choose to certify through heating demand, and you need to be meet either 4.75 kilobTUs per square foot per year or lower. If you have if you're, say, in Southern California, if you're in a desert climate, your cooling demand might be actually a more stringent requirement, and you might want to certify through the cooling demand criteria. Or alternately, you can certify to the heating load criteria, which is 10 watts per meter squared in metric and 3.17 BTUs per square foot are in inch-pound units. So that's the first one, is to do with just reducing your overall heating and cooling load and demand for your building. The second one, as I mentioned earlier, is your air tightness requirement. So this is tested with a blower door. Your building for certification has to have this third-party tested and documented to the certifier before you can receive the certification. And another part of that air tightness is actually your ventilation system also has to be tested, or the ducting tested and balanced, so that each room is verified that it is receiving the right amount of ventilation for the size of the room. So that's another part of that certification requirement. And then the third passive house certification requirement is the source energy demand. And we typically are used to hearing EUI, energy use intensity. And this is very similar. And this is your overall energy demand for a building, and includes elements like your lighting efficiency, all your appliance efficiencies, and it's calculated not where it's used at the building, but actually where the energy is generated at the source. And this is quite interesting to look at. And this is where the classic passive house standard, you can see the image I have on the left there, has recently been updated. The Passive House Institute is looking to the future, where the entire energy grid will be all renewable energy source. And they're looking at the various renewable energy generation systems, and actually weighting them by their efficiency and also their ability to be stored, both short-term and long-term. And they're each given what's called a primary energy renewable factor. So there are now actually 3 classifications for Passive House certification, and you can see them on the left. The classic one is the original Passive House standard. The Plus incorporates some renewable energy on site, and as does the Premium, and those are factored by how much renewable energy is being used on site. And there's a very interesting calculus for how the renewable energy is factored, because it's considered by the amount of area on the ground that the building actually is occupying, which is allowing buildings that are multi-story that would not be able to zero themselves out because they just don't have enough roof area to the amount of interior volume to also receive the Premium standard, because it's a weighted balance between the amount of renewable energy and roof area that each building has compared to the amount of floor area. So it's considered a sort of more equitable approach than the classic net zero, where some buildings will not be able to be zeroed out because they simply don't have enough roof area. So let's move on to some examples. Here we see up to date, this is currently still the tallest passive house, certified Passive House building in the world. It's a bank in Vienna that I was very lucky to visit and be there for the certification ceremony. It's an interesting story. This is an Austrian bank that bought the buildings. You can see on the left there, the image is the sculpture with a hand and the oil rig. These were former OPEC oil buildings that this bank bought and has renovated. The 2 buildings on the right there, on either side of the central tower, have also been renovated to a Passive House retrofit requirements, and the tower is in the middle is the new building that is Passive House certified. So this bank has sort of really gone snubbed its nose at the fossil fuel industry and is going towards this ultra energy efficiency standard for all their new buildings. And it's a really lovely building. You can see here's the interior of the top floor where we held the certification ceremony. And this image to the left actually shows how they used a typical glass rain screen exterior envelope to the outside. And then the thermal envelope is the triple glazing system to the interior. So it has a double skin building envelope. So it looks very similar to a lot of glass tower buildings, but actually has this really super insulated interior layer that moderates and gets it to be to Passive House insulation levels. And shading on this building is also very tightly controlled. So this is a picture of the interior atrium. Lovely lighting all throughout this building. The design features in this building were spectacular. It was definitely a high budget project, no expense spared. And here again is another picture. I was on a tour of a whole bunch of Passive House people from around the world. We got to visit this particular building. We went, the next building we visited was actually a justice center. This is the courts, the legal offices, and both administrative offices and court offices for this region just outside of Vienna. A very lovely building that actually also has a prison in the just right across the parking lot from this particular building. We didn't go into the prison, but it was very interesting to see the security measures that this and the challenges this particular building had to overcome, because it still had to have all the typical metal detectors and high security doors for this building. But this is the exterior. You can see on the right there, very careful shading. When you super insulate and you air seal and you make this building really efficient, you have to moderate the amount of sun that comes in, and exterior shades are really still the optimum way to do that. You can see you only need them on this is the south side on the right, and on the left there is actually must be the east side, and on the left there is the north side, so doesn't need the shades there. The revolving door on the right there was a very interesting challenge for the thermal bridging. It was a custom designed revolving door, and these have subsequently become available on the market because projects like this one have sort of pioneered the idea of making these thermal bridge free. Just some shots of the interior atrium. Lots of beautiful light into these three interior light wells in the building. And I will go up onto the roof. Here's another shot of one of the interior courtyard rooms. Some of the interior hallways. And this is the mechanical room where we all toured. It was very carefully designed and beautifully laid out. One of the nicest mechanical rooms that I've been in. You could have had your lunch in this room. It was so meticulously clean. And I always laugh that, these were Passive House advocates and architects and engineers from all around the world, and where we all end up being was in the mechanical room, which is sort of ironic, because it's the active systems that actually are quite challenging for all these buildings, because the loads are so low still. Just a few more images of the interior detailing. There's no excuse for a bad design in a Passive House. There's lots of opportunities for making these just as beautiful as conventional buildings. And this is the picture on the roof deck. I wanted to show this because behind the planter there, that's the skylights, and there are retractable covers that can be pulled across those skylights to, again, control the amount of sun that comes in. Vienna does actually get a really hot summer, and overheating is something that has to be very carefully detailed and designed for passive houses, and indeed for any low energy buildings. You have to make sure you don't overheat. Another one on the outside, that's the prison up opposite where I was standing on the deck. There was one prisoner in there who was at his window. So moving on, another project. This is a project that Andrew Mitchler photographed. It's the Art Museum in Ravensburg. It's an old medieval city in the southern part of Germany that has built, essentially renovated part of an old structure and turned it into this magnificent art museum. And it's a great illustration of how the passive house can be applied to many different building typologies. The entry door, they had the same issue as the Justice Center with the revolving door. You want to make sure that this was thermal bridge free, and this door was again custom designed for the museum. Just an interior shot. This building has won multiple architecture awards. It is really a lovely space for art, and also very well temperature controlled. Not many windows. The other thing for passive house is if you actually don't have too many windows or not enough access to the passive solar gains, you can still build a passive house. So this is the hallway. There's a few punched openings there you can see, but generally the art museum does not have a lot of daylighting. And the mechanical systems, you can see quite extensive and complex mechanical systems. Mechanical engineers play a very critical role in good passive house design, because actually getting the ventilation flows right, and the heating and cooling distribution is a very essential part of good passive house design. And on the right there, the threshold at the doors. This is a very important junction. Thresholds are notorious for both being poorly insulated, so being big thermal bridges, but also being hard to air seal. So the devil is certainly in the details for passive house, and this is no different. Some social housing and multifamily projects that I built, this whole neighborhood in Vienna, all of these buildings are built to the passive house standard, and just quite an interesting variety of them. I toured these. There were still many of them under construction. Housing is quite affordable in Vienna, and they have lots of subsidized housing that's for normal people, and was quite impressed with the design and the variety available. This is a hotel in Vienna that was renovated. On the right there, you can see the new part. And there's a tower there that has the solar panels installed vertically on the south side. The left side is the old building. They actually removed all the ivy and insulated that building from the exterior, added new windows, and installed a really good ventilation system. And this building is a very popular hotel. It's booked out for most of the year, and it's very hard to get into because it's known for being such a comfortable place to stay. The University of Vienna was building a new science laboratory. That's also passive house. The building on the right there, you can see it's still under construction. There was an office park outside of Vienna that we visited. This is one of the buildings that is a passive house, and again, the most notable feature of this is the shading. It's very critical for good passive house design. Social housing. This is an affordable housing development, 1,500 apartments. Right near a metro stop. Here's another view of the street side. There are some commercial buildings, not on this particular side, but on the facade that you can't see around the corner there. And we spoke to some of the occupants, and they just loved these buildings. It was a wonderful place to live, very comfortable. And student dormitories. This is at the university in central Vienna, and all these dormitories are built as passive houses. I stayed in this dormitory, and actually it was incredibly comfortable and nicely modulated. Bahnstadt in Heidelberg, the old train yards have been removed to further outside of the city and opened up a huge plot of land for development, and the city required that all the buildings built in this tract of land have to be passive house buildings. So there's a really incredible mix of apartments and office buildings that are all being built in this development as passive houses. Some of them are quite spectacular and interesting. This is an office tower. You can see on this left facade it has operable shades. Those white cladding panels actually articulate up or down depending on how much light the occupants want. And it's really a beautiful design, very sophisticated office tower. Here's another one of those showing those articulated shading structures to help with the temperature control. Some of the apartments, those are sort of row house, townhouse apartments, very classic sort of contemporary design. A couple more in the same development. This is another one. And here are some details. Thermal bridge free window installation on the left. And some insulating, the product on the right there is an insulating EPS that has a graphite content that actually improves the insulation value of that particular material. Some of the interior shots, this is the ventilation system. The ventilation system also has sound baffles. So those big round sort of cylinders that look like car mufflers are sound baffles because it's interesting. Passive house buildings have incredibly wonderful acoustics, but you have to be very careful with the equipment that you specify for them, because sound is really magnified inside a passive house because these buildings are so well insulated and so air sealed. So they have an incredibly peaceful interior quality to these spaces, but as I say, can be easily wrecked by a poor quality ventilation system that when it turns on, it's just noisy. So bringing it home, this is a project in Colorado. It is Andrew Michler's house that he built. Is actually on his property up in the foothills of the mountains outside of Fort Collins in Colorado. So colder climate, but also hot in the summer. And I'll just look at some of the details. Obviously, that climate is a lot chillier, and you can see he's using quite a thick wall insulation assembly. He's designed this to be a foam-free project. So his walls, he built those Larson trusses to the exterior of the interior frame, and that all got filled completely with blown-in cellulose insulation. Here's another shot looking at the thermal bridging at the floor. He did a raised floor that was also filled with cellulose insulation because he was using a partial retaining wall that was existing at that particular location. And this is a project of mine here in Oakland. It's a renovation of an old garage. It's not quite to passive house, but I used all the passive house methodology. The only thing that didn't quite meet the air tightness, the standard was the air tightness. But you can see this is all the same principles were applied, and it was modeled. We modeled it in the PHPP to see exactly how much heating and cooling we'd need. We insulated around the perimeter of the existing footing. Renovations are a lot trickier. You don't get to design optimal assemblies, so you get to be really creative about how you build these projects. So this is a product on the right there called foam glass that we installed all around the perimeter footing to minimize the thermal bridge there. This is an image of the air sealing strategy. We used plywood that was taped at all the seams. It's the shear layer. And we extended that same layer all the way up to the roof to make this continuous airtight envelope. And you can see also the plywood was connected to the foundation, the perimeter footing there with the tape. And that's the finished product. We reused all the redwood siding on the original garage. You can see the picture on the left there. We removed them in the boards and replaned the old paint off them and then reinstalled them. So it was quite a fun project. It's now being used as a yoga studio and has quite an innovative ventilation system installed that actually does not have heat recovery. We're using bathroom extract fans on a timer that are connected to an inline damper. You can see the images down below in the middle. The two vents are at the top of the gable. The extract vents are there at that end wall, and the intake vents are at the other end of the building gable. And it's an incredibly comfortable space. The one item that is missing from this, and it was designed but has not been installed yet, were the exterior shades, and those will be by the end of the summer. Those will be installed. I can pretty much guarantee that. This is a science building at a school in Germany. I'm just going to flip through this real quickly. A really beautifully designed project with lots of bells and whistles and nice interior detailing. And the monitoring on this is really fascinating. The operations manager for the building compared the existing old building to the current building, and he tracks and keeps monitoring data on the building performance. And you can see on the two bar graphs to the right of that chart, sorry, it is in German, but the numbers actually are universally understood. In 2010, the energy use for the building was at 79.6, and in 2011, he had even optimized the building through his tracking and monitoring, and the use went down. But you can see this building is actually operating better than the Passive House standard, which is the middle bar, and a whole lot better than older buildings and standard new construction buildings. So this is another feature of Passive House buildings. Many people monitor the performance and track the use, the energy use of their buildings, and they are consistently shown to actually perform very close to how they were modeled. And my own projects, we've been doing this as well, and I can verify that this is working really well here in California. It's certainly applicable everywhere. So this is my last slide, and I'm going to hand it back to Lizzie. But I just wanted to show these are projects here in California that are all using Passive House, and they've been modeled with the PHPP. And we are working on getting a significant study done to really track the performance of these projects here But so far, the ones that we have seen monitored are doing extremely well. And we are looking forward to expanding the number of projects here in California and participating with the rest of you on that. Thank you for your time. I'm going to hand the screen back to Lizzie. And there we go. Lizzie, you're good?
Thanks, Bronwyn. Yep, I've got it.
Okay, great.
So after that, the question really becomes, how do you start getting Passive House into your project? And I think, some of the best ways to start is to consult with a Passive House expert. And there's a lot of ways you can find. As Bronwyn might have mentioned, there's 2 different kinds of metrics. And similarly, there's 2 different certifying bodies. So, and each of them have a program that certifies Passive House consultants. So there's the international group, Passive House Institute, and there's the domestic group, FIAS. And we can send out these links to anyone, but they each have databases of certified professionals that are able to help you with any stage of design for a Passive House project. And additionally, there's a lot of local events, which we'll go through, as well as a lot of national events. So NAPHN, which is a cooperative of a lot of different groups around the US and Canada and Mexico, runs events as well as a national conference this year, which will be in New York. And FIAS, which also has affiliate groups throughout the US, and also has a conference, which I believe is in Philadelphia this year. And each of them run training and events throughout the country. And locally, though, we have some upcoming events. So I know earlier I put on a whole list of events. We have a mix of events. Some of them are technical training. Some of them are more casual events. And the soonest kind of casual event is there's going to be an open house in San Francisco on May 14th with some more details to be provided on our website. So all of our events are listed on our website, so check it out and you'll find all the details there. May 19th and 21st, we're very excited to be hosting a Solar Decathlon Slam where we'll look at how Passive House fared in the Solar Decathlon. And we have Ed May coming, who won the Solar Decathlon, and he's going to be sharing his lessons learned and how that all relates to Passive House. We're going to be able to deconstruct the projects that we're presenting. And we're hosting that twice, once in San Francisco up in the afternoon and on a Thursday, and once in Palo Alto on a Saturday in the afternoon as well. So find more events. You can find more details on our website. Later on the year, we'll have a homeowner panel in August, and then a materials showcase and Petal House tour in November, and our holiday party at AGM in December. In terms of technical training, where if you really want to take your practice to the next level, if you want to learn more about how to implement Passive House on a project, this is where you should look. We have a very rigorous Passive House consultant designer training led by PHA coming up soon. And I'm going to talk a bit more about these events in detail. So the consultant designer training is a very rigorous program, and everyone I've talked to who's taken this program has just found it's really revolutionized how they approach design. So it's kind of a overview of what you'd learn. It starts off with just a definition of what Passive House is, energy balance calculations, the basic principles of designing Passive House buildings, looking at all the specific elements such as the thermal envelope, windows, thermal bridging, air tightness, and then looking at the active side, so the ventilation, heating, and cooling of Passive House projects. And then looking at the economic efficiency calculation, which is a big point of discussion for Passive House projects. Then the construction and site management and quality control, which is a critical part of Passive House because there's so much that goes into a Passive House. Knowing how to do this on site is really half the challenge. Designing it may seem like the biggest part, but it really ends up being how do you put this into practice. And then just a short one-day introduction to the Passive House planning package. And this program has been recently restructured so that the PHPP, or the Passive House Planning Package, most of it has been taken out so that they can make the class more focused on the technical details of how to design a passive house. And then you're able to take the PHPP class later in your own time. They've also structured it so that you have, instead of a 10-day class, it's a 5-day class plus 3 days online when at your own leisure. And then we will be hosting the exam later in June. So it's 5 days of in-classroom training, and it'll be held April 12th through 16th. And it's really focused at anyone who's a design professional. So whether that's a builder, an engineer, an architect, and it does have AIA credits. The next class we're hosting is Andrew Peel's coming down from Ontario to teach a 3-day PHPP Passive House Planning Package class. And this is a 3-day intensive introduction to PHPP. And the PHPP is designed as an approachable, kind of simplified way on energy modeling. And if you know anything about energy modeling, you know that learning a software in 3 days means it must be a fairly reasonably simple piece of software. So this is going to give you all the skills you need to understand how to use the PHPP in your projects. And the PHPP has even though it's a very simplified methodology of calculating energy, it's been found to be very, very accurate in and I think I just started screen sharing. The PHPP has been very accurate in actually predicting actual energy demand, which is actually rare. So the PHPP is going to break down all your energy losses and gains and allow you to see what the biggest part of the pie is. So you've got here, what you're seeing is just a screenshot from the PHPP. This is just one of the tools that's built into the software. And you can see on the left your transmission losses. This is conduction, and your ventilation losses. You know, in this building, you'd look at this and say, okay, my transmission losses, you know, you can see which part is really dominating. And so this is, you know, this is the goal, is to help you use the PHPP in your building design and certification. And it's, as I said, it's May 9th through 11th, and you can sign up. There's a link on our website to sign up. And the second class that he'll be teaching is the Design PH class, which is a 3D interface with PHPP. These images are images of what your building would look like when you create it using SketchUp. So SketchUp is a very easy to learn 3D modeling tool. And this plugin has been designed so that you can draw your building in SketchUp and then identify all the elements in your building. So you're able to, and you can see here, the windows are showing up as purple, the walls and roofs, your enclosure is showing up as red, and your shading device is showing up in white. And so you're able to, instead of manually inputting each of your elements in a spreadsheet, which is PHPP, you're able to design them in 3D and then identify them, tell them which is which, and import it directly into the PHPP. You're also able to get out some quick, rough order of magnitude heating and cooling numbers to help you design your buildings using this tool to get a first initial sense of how your building is doing. So this class is going to be taught straight after the second one, May 12th through 13th in 2016. And we're really excited to have all of our trainers here. So at this point, we're going to open it up to any questions from any of you guys. And I think just going to see. So if you guys have anything that you'd like to discuss or have any questions, please let us know. And you can. So if you guys have anything that you'd like to discuss,
Lizzie, I'm not sure if I'm audible again.
Yes, you are.
All right, thank you. So I would also like to just add that if we're going to be posting this has been recorded and will be on our YouTube channel for reviewing or for sharing with others. And anybody is also very welcome to email us at Passive House California with any follow-up questions. So our email is info@passivehousecal.org. So Passive House, all spelled out, CAL.org. Yeah, feel free to connect with us directly through our website.
Absolutely. And one thing I didn't add here, I'm just going to go back a couple of slides. We have our local training programs here. And what we have is we've developed this survey. So if you're interested in training, but you haven't seen the training that you're all interested in, go to this link. We'll also put this on our website, and just tell us what you're interested in training, and then that'll help us design a training program oriented towards your training needs. And if you do want to make any comments, you can post them on the YouTube or the Google Plus websites. We can see them.
Right, so if there are no questions for us today, we will look forward to meeting you and hearing from you through our other channels. And we hope to see you at some of our upcoming events. Thank you so much for joining us.
Thank you very much.